And good morning. Okay, we're going to go ahead and start chapter 3 in book 2, exploring unknowns and equations. So let's look at 3.1. So in the first chapter of this book, we reviewed the big picture of math. In the last chapter, we looked at a few core notations we use to describe quantities and consistencies. So basically, in chapters 1 and 2 of this book, we've gone over to make sure that you know and you understand the basic mathematical equations that you'll come in contact with, most all of them. So now it's time to start exploring solving problems involving what we call unknowns. As we do, we'll apply and build on those principles and notations that we've looked at so far. We're just going to kind of add another little thing to it. All right, so understanding unknowns. So the word unknown is a short way of writing an unknown quantity. While you may not have formally looked at unknown quantities or unknowns before, you've encountered and worked with them informally for years. So for an example, say you went to the store and you bought a music CD. The store was running a special. You could get 4 CDs for the same price as one. If you were planning on buying one CD anyway, how many additional CDs would you get because of the special? We can think of the number of additional CDs as an unknown. So you could use a question mark to represent it. So this would be your equation. So 1 plus how many more would be my 4? Well, you know to get from 1 to 4 you need 3. So the unknown in this case is 3. Now, that kind of thing, of course, you wouldn't even think about that as being a mathematical equation. You'd just simply know it. But it's just kind of showing you what an unknown is. Okay? All right, let's look at the next page. So another example of unknowns, consider the relationships between aspects of shapes. So back in book 1, when we were looking at geometry, we discovered that the consistent relationship between the area, length, and width of a rectangle is always the same. The size of the rectangle might change, but if a shape is a rectangle, its area will always equal its length times its width. So right here, using a formula, okay, notice they're using letters as placeholders, which we've done before. A for area equals L for length times width. Okay, those letters represent unknown quantities or unknowns. We didn't specify the exact value of the area, length, or width. Instead, we used symbols, in this case letters, to stand for those quantities, whatever they were. Now, by using letters to represent the area of a rectangle, we represented a mathematical relationship. In this case, the relationship between area, length, and width in any rectangle. We use the knowledge of this relationship then to find the area of various rectangles. Now, before we go on, I want to read this little section right here. Now, the letter we use to represent an unknown doesn't really matter. You'll notice that math books tend to use X, Y, and Z, or A, B, and C. There's a reason why those particular letters are used most frequently. It's due to a convention that we'll talk about later on in chapter 13. Now, we've dealt with unknowns when working with word problems. For example, there's a relationship between the number of people in the family attending an event, the cost per person, and the total cost for the family. So here's an equation. The total cost for the family would equal the number of people in the family attending times the cost per person. Or more simply, dun, 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 the T, N, and P in this equation are all unknown quantities or unknowns. We didn't specify how many people there were in the family, how many would be attending, or the cost per person. Instead, we just use letters to stand for the total cost, the number of people in the family attending, and the cost per person. We'll often use letters as placeholders for unknowns. In fact, we could have used a letter back in the CD example, the very first example we had, instead of a question mark. Which letter we use isn't important. The letter is but a placeholder to stand for a quantity. So this is what they used, 1 plus question mark equals 4. That's what they used on the very first page. But here they decide to use C, or here they decide to use X. Now, this one right here is what I want to talk about for just a second in this little gray box here. To avoid confusion with the letter X, We will not use X as a multiplication sign in problems containing unknowns. Instead, either use a dot or parentheses. So just go ahead and get used to that now. Anytime you're doing multiplication, just use a dot or just, parentheses, either way. Let's look at the next page. Now, we often use letters as placeholders for unknowns. There's nothing to say we have to use letters. In the past, many would refer to an unknown using a word such as heap or casa, which means things. I don't know if that's how you spell it, cosa maybe. Hindu writers use the abbreviation ya to refer to an unknown number. Different symbols have also been used. For example, the Greek mathematician Diophantus used this symbol, looks like an S with an apostrophe, to refer to an unknown, while Stephen used this. Letters are just a way of representing unknowns. Okay, so let's read this box. The gray boxes with the arrows are always pretty important. Just as we use numbers to name quantities. 1 names a single quantity. 2, to identify. The numbers in a telephone number. Identify a specific telephone line. And to order, such as the 5th most popular song of the year. We also use letters to name quantities. X names an unknown quantity. Identify license plates. Use license plate. Use letters as well as numbers to identify a plate. And to order, might use the first line in a list as A, the second B, etc. So like numerals, letters are a helpful naming tool. Now this gray box is important because on your worksheet, the last question is going to bring you back to this box. Okay? While we use letters, we use them to name, to identify, and to order. That's what you need to know. Alright, now as we begin applying the same principles we've been using to work with known quantities to unknown quantities, which we call unknowns, keep in mind that the letters you'll begin seeing are merely placeholders to stand for a quantity we've not yet specified. They're additional symbols we use to help us describe God's creation. Alright, so with that being said, let's then look at worksheet 3.1. There are 2 pages to it. I'm going to look at this right quick. It's very, very simple though. Okay, now you can either copy it from the screen, or if you have the book, or if I've printed you a page out, it doesn't matter. Alright, so we're going to list the number the question mark is standing for in each equation. Okay, so example, 5 minus question mark equals 2. The answer is 3. So right here, 9 minus question mark equals 7. Here's an example meaning. We had 9 cookies on a plate and only 7 are left now. How many were eaten? Well, the answer is 2. So the unknown stands for how many were eaten, which was 2. So your answer is 2. Okay? On this one, 1 plus however many equals 7. An example might be, if we have finished 1 page of a book, how many more pages do we have left to finish 7 pages total? Well, that's easy. The answer would be 6 pages. Question mark equals 6. So your answer is 6. Okay. This one, 6 minus how many equals 6. If you started with $6 and you end with $6, how much did we spend? 0. Okay, 5 times what equals 30? Here's an example. If we have 5 problems to solve, how long can we spend on each problem if we have 30 minutes in which to solve them all? The answer would be 6. Okay, right here, something, question mark, divided by 5 equals 9. An example, if we can't remember how long it took us all together to complete all 9 problems, but we know we spent 5 minutes on each problem, how long did it take us all together? 45 minutes. So your answer there would be 45. Alright, now let's look at, that's just some very simple exercises, just making sure that you're identifying the unknowns. Alright, here's more unknowns. Okay, so we're going to list the number x is standing for in each equation. So 2 plus x, we're using x as the unknown, equals 11. Example, if we put together 2 flower bouquets for a wedding, how many more bouquets are needed if we need 11 total? So your answer would be, make sure you put x equals 9. Okay, you need to get into that process of telling us what the unknown equals. Okay, so 20 minus x equals 14. Example, if we start a trip with $20, how much can we spend if we need to end the trip with $14? So in this case, x equals $6. Okay? All right, look at the next page then. Now, I'm going to go ahead and let you finish this. I'm not going to grade this page. It's just getting used to these x's. Now, make sure, though, that when you look at the problem, make sure you read this example because it kind of puts it in your mind as to what we're working with here. Now, on this part, let me go over this with you right quick. It says, go back and look at the example meanings for the requested problems. If we were using the equation to solve that example meaning, what would the x represent? Here's an example. In problem 2e, the answer was, here would be 5. So your 5 would be the x. So what does x equal? If in a board game we started a certain number of spaces from start, moved 3 spaces away from start, and ended 8 spaces from the start, how many spaces from start were we before we moved 3 additional spaces? So whatever the x equals is what you're going to put here. So the x this is the answer. The x represents how many spaces from start we were before we moved 3 additional spaces. So right here on A, you're going to go back to problem 2A and see what the answer was and see what that x represented. And so your answer will be something like, the x represents blah, blah, blah on each one of these. Okay? And then this right here, this 5B, is, remember what I told you, you'll have to go back to this right here. This is why we use letters. So that's what you'll have to do in there. Okay? All right, so go ahead and finish that up, and that will be all for this lesson.